All right, get ready, because today we're going deep into a world that most people don't even know exists.
Oh, okay.
U.S. regulations for facilities that transfer oil and hazardous materials in bulk.
Yeah.
Think of it like the behind-the-scenes rules that prevent those headline-grabbing oil spills.
It is a fascinating area
Yeah.
where safety and environmental protection
Right.
meet some serious engineering and meticulous planning.
Exactly.
Yeah.
And we're going straight to the source for this one. No summaries or interpretations.
Okay.
Just the raw, unfiltered electronic code of federal regulations.
Right.
Specifically, 33 CFR Part 154.
Okay.
Ready to get your hands dirty?
Let's do it.
Okay, first things first, who needs to pay attention to these regulations? Who are they actually for?
Well, if a facility can transfer oil or hazardous materials to or from a vessel that holds 250 barrels or more,
Okay.
these regulations apply.
Right.
It's like a risk threshold,
Hmm.
250 barrels, which is about 39.75 cubic meters.
Okay.
That's where the potential for a serious incident really kicks in.
250 barrels. That's oddly specific.
Yeah.
It's not like they pulled that number out of thin air, right?
Right. It's all about creating a consistent standard,
Okay.
regardless of whether you're dealing with crude oil, gasoline, or some other hazardous liquid.
Gotcha.
The regulations also make it clear that offshore facilities under the Department of Interior's jurisdiction
Yeah.
have their own set of rules.
Okay.
Different territory altogether.
So let's say a facility meets that 250 barrel threshold.
Okay.
What's their first step towards becoming compliant with these regulations?
They need to create what's called an operations manual. And this is not your average employee handbook. This manual is a legally required document.
Right.
And the captain of the port can show up at any time and demand to see it.
So no hiding this one in a dusty filing cabinet.
I'm absolutely not. Think of it as the facility's Bible
Okay.
for safe operations.
Right.
It starts with the basics, like a description of the facility,
Mm-hmm.
its hours of operation, what kind of vessels it handles. Okay.
But then it gets granular, like
Yeah.
really granular.
Okay, I'm intrigued. Give me an example of just how detailed this manual gets.
For each and every product that moves through that facility,
Right.
they have to have a full profile.
Okay.
Like its fingerprint.
Yeah, huh?
We're talking the generic name,
Yeah.
what it looks like, even what it smells like.
Interesting.
And, of course, a rundown of all the hazards,
Right.
specific steps for safe handling procedures, for if there's a spill,
Yeah.
and even how to fight a fire if that product ignites.
Wow, that's intense. It's like a recipe book gone wrong.
Yeah.
A little bit of this, a little bit of that, and boom, you've got a major incident on your hands.
It's all about being prepared for every possible scenario.
Yeah.
And clear communication is key.
Right.
The manual actually has to include translations for anyone in charge of transfer operations.
Oh, wow.
If their primary language isn't the one you use at the facility,
Really?
you can imagine how disastrous a miscommunication could be
Oh, yeah.
in this kind of setting. That's a scary thought. So we've got the playbook, the operations manual.
Right.
But what about the equipment itself?
Yeah.
Are there rules for that?
Do
too?
bet. The regulations go deep on the equipment side as well.
Okay.
Hose assemblies, for example, have to be designed to withstand a lot of pressure,
Okay.
at least 4 times the pressure of the relief valve setting,
Uh-huh.
or the maximum pressure from the pump.
So basically built like tanks
Yes.
to handle any unexpected surges.
Hmm.
What else?
Even the markings on the hoses are regulated.
Really?
They have to clearly display the names of the products they can carry.
Uh-huh.
For oil, it's straightforward oil service.
Oil service. Got it.
But for hazardous materials,
Yeah.
you'll see Hazmat Service C list with a symbol.
Hold on, a symbol. What's that about?
That symbol directs you to a chart.
Okay.
In, you guessed it, the operations manual.
Of course.
This chart lists every single product
Wow.
compatible with that specific hose.
It's like a visual failsafe.
Yes.
Forcing you to double check before hooking anything up.
Right.
I can see why they'd want to be extra careful.
Exactly. And speaking of connections,
Yeah.
loading arms,
Mm-hmm.
those big articulated arms that connect the vessel to the shore
Okay.
are tightly regulated too.
Right.
Any loading arm installed after June 30th, 1973
Wow.
has to meet strict ANSI standards.
1973. Those regulations have been around for a while.
That's right. And just like hoses,
Yeah.
there has to be a way to drain or close them off
Okay.
before they're disconnected, minimizing even the smallest drips or leaks.
So it's all about containment.
You got it. They even require things like butterfly valves or blank flanges, which are basically like plugs,
Uh-huh.
to seal off any disconnected equipment.
Right.
Every potential leak point has to be addressed.
Okay, I'm getting the picture. A carefully designed system
Yes.
with multiple layers of protection.
Right.
But what happens if, despite all these precautions, a spill does occur?
Well, that's when things get even more interesting.
Okay.
The regulations require facilities to have a system for containing smaller spills, especially in high-risk areas, like where hoses are connected or manifolds are located.
Yeah.
Think of it like catch basins or curbs designed to funnel any spills into a safe area.
So even a little spill is treated like a big deal.
Absolutely. And the size of these containment systems depends on the size of the hoses being used.
Okay.
A hose with a 12-inch diameter or larger needs a containment system that can hold at least 4 barrels.
Okay.
Larger hose, bigger potential spill, bigger containment needed.
Yeah.
Makes sense, right?
That's logical.
Yeah.
But what about facilities where building fixed containment just isn't practical?
Right.
Maybe due to space constraints or a unique setup?
The regulations are flexible enough to allow for portable containment in those cases.
Oh, okay.
As long as the captain of the port approves it.
Gotcha.
It's a good example of how the rules try to strike a balance.
Right.
Between being strict and being adaptable to different situations.
Adaptability is key. So the spill is contained, at least the smaller ones.
Okay.
What happens next?
Speed is of the essence.
Okay.
Facilities are required to remove any spilled material within 1 hour of the transfer ending.
Wow.
And they can't just wash it into the water.
Yeah.
It has to be removed safely and properly.
1 hour. That's putting the pressure on.
It underscores the urgency of the situation.
Yeah.
And the need for a swift and effective response.
Right.
And speaking of response, facilities also have to have access to enough containment material and equipment to handle whatever might spill.
Right.
This doesn't mean they necessarily have to own all of this equipment. They can share resources through agreements with other facilities or even have contracts in place.
So it's about being prepared, not necessarily about having a warehouse full of gear.
Exactly. And the captain of the port has the authority to get even more hands-on. They can actually require a facility to surround a vessel with containment material before a transfer even begins.
Wait, really? So not just cleaning up spills, but trying to prevent them from even reaching the water in the first place?
Yeah.
That's thinking ahead.
It is. And that proactive approach is also reflected in a surprising area. Lighting.
Lighting. You're telling me there are regulations about how brightly lit these facilities have to be.
Absolutely. Between sunset and sunrise.
Wow.
Any facility conducting transfer operations has to have fixed lighting that illuminates all the crucial areas. We're talking transfer connection points, work areas, and even any barges involved in the transfer.
So no stumbling around in the dark trying to hook up hazardous materials. Good idea. But what about the brightness?
Yeah.
Do they have specific lumens or something?
They do 5.0 foot candles at connection points.
Wow.
And 1.0 foot candle in work areas.
Specific numbers. They really thought of everything.
And that attention to detail extends to the people involved as well.
Okay.
The regulations emphasize the importance of having a qualified and well-trained person in charge of transfer operations.
So it's not just about equipment and procedures.
Right.
It's about having a competent captain steering the ship.
Exactly. And the requirements for this person in charge are pretty rigorous.
Okay. I'm all ears.
Yeah.
What kind of training and experience do they need?
At least 48 hours of experience in transfer operations. Plus enough facility-specific experience to make the operator confident in their abilities.
Gotcha.
Then there's the training program. And it's not just a quick safety video. We're talking in-depth instruction on everything from the hazards of the products being handled to emergency response procedures. And here's a little twist. If someone has already completed training for OSHA or EPA hazard communication programs, that can actually count towards some of these requirements.
So they're not reinventing the wheel. They're building on existing safety standards.
Exactly.
But what exactly does this person in charge do?
Yeah.
I mean, besides having a cool title.
They're responsible for making sure everything runs smoothly and safely.
Okay.
Which means enforcing a whole laundry list of safety rules.
Right.
Think no smoking signs.
Yeah.
Designated areas for vehicles.
Right.
Fire extinguisher checks.
Yeah.
Spark arresters on equipment.
Okay.
They're like a walking safety checklist.
Wow. So a lot of responsibility rests on their shoulders.
Absolutely. And for mobile facilities, which are inherently more dynamic and potentially hazardous, there's an extra layer of precaution. They need warning signs at every shoreside entry point while they're connecting, transferring, and disconnecting.
So we've got the playbook, the equipment, the spill containment, even the lighting.
Right.
We've covered a lot. But there's one thing that keeps nagging at me.
Okay. What's that?
You keep mentioning oil and hazardous materials, but are we really just talking about typical oil facilities here?
That's where things take a surprising turn. All these regulations apply to a much wider range of facilities than you might think. We're not just talking about your classic oil refinery.
Okay, now I'm really intrigued. Tell me more. Who else falls under this regulatory umbrella?
We're talking about what are called marine transfer facilities, or MTRs for short.
Marine transfer facilities, MTRs.
Got it. This broad term covers any facility that handles oil in bulk.
Okay.
And there's a whole classification system based on the potential environmental impact.
So different levels of risk.
Yes.
Different levels of scrutiny.
You got it. We have substantial harm facilities and significant and substantial harm facilities.
Okay.
A deep water port, for example, would fall into that higher risk category.
Right.
One mistake there.
Yeah.
And you could have a disaster of epic proportions.
Makes sense.
Yeah.
So what would be an example of a substantial harm facility?
Think about your typical onshore facility that transfers oil to or from vessels holding at least 250 barrels.
Right.
Even those mobile facilities we talked about earlier fall into this category if they're designed to transfer oil to vessels of that size.
Okay, I'm starting to grasp the scope here.
Yeah.
And it's way bigger than I initially imagined.
Right.
But what happens after a spill?
Okay.
Especially a major one. Do they just scramble to clean it up and hope for the best?
That's where the concept of response plans comes in.
Okay.
They're like a facility's insurance policy, outlining exactly what to do if or when things go wrong.
Right. So they can't just wing it?
Nope. These plans are mandated.
Okay.
And they have to be incredibly detailed.
Right.
We're talking about blueprints for every possible spill scenario, including the absolute worst case scenario a facility could face.
Okay, so that everything goes wrong plan. I can't even imagine putting that together.
It's about anticipating the maximum amount of oil or hazardous material that could be released and having a game plan to handle it.
Right.
But they also need to consider more likely average spill scenarios.
Okay.
Based on their specific operations and history.
So covering both ends of the spectrum, the apocalyptic spill and the this could actually happen spill.
Precisely. And there are guidelines for determining both of these scenarios.
Right.
They have to analyze their facility's layout, storage capacity, transfer rates, and even their past spills to figure out what they need to be prepared for.
Right.
It's a lot of data and a lot of risk assessment.
I bet. But it's better to be over-prepared than under-prepared?
Absolutely.
Especially when it comes to something as potentially devastating as an oil spill.
Absolutely. These response plans are a facility's lifeline in the face of a spill.
Yeah.
And we'll be diving into the details of those plans in the next part of our deep dive.
Yeah.
Stay tuned.
I can't wait to unravel the mysteries of those response plans. Welcome back. We're picking up right where we left off.
Okay.
Ready to tackle those all-important response plans.
These plans are more than just a stack of paper.
Right.
They're a facility's roadmap
for
navigating the chaos of a spill, big or small.
Last time we talked about the worst-case scenario.
Right.
But response plans have to cover a range of possibilities, right?
Absolutely. They need to address both.
Okay.
The worst-case discharge and the average, most probable discharge.
So two very different scenarios.
Right.
Requiring very different responses.
Exactly.
How do they even begin to determine what those scenarios would look like?
It involves a deep dive into the facility's data.
Okay.
Looking at everything from their layout and storage capacity to transfer rates and past spill incidents.
Right.
They also need to factor in things like the types of oils or hazardous materials being handled, weather patterns, and even the time of year. It's a complex calculation with a lot of moving parts.
It sounds like they need a whole team of data analysts
Yeah.
just to figure out what they're preparing for.
It's a significant undertaking,
right?
But it's crucial for developing a response plan that's both comprehensive and grounded in reality.
So they've got their worst case and average case scenarios figured out.
Okay.
What exactly goes into the response plan itself?
The regulations lay out a very specific structure for these plans, ensuring consistency and clarity across the board.
So, like a blueprint for disaster preparedness.
Exactly. The Emergency Response Action Plan is the heart of the document. And within that section, there are specific requirements for notification procedures, spill mitigation response activities, protecting fish and wildlife, and even a disposal plan for any recovered material.
Let's break those down one by one. Starting with notification procedures. Who needs to be alerted in the event of a spill? And how quickly do they need to be contacted?
This section is all about communication. Who needs to know and how fast can you get the message to them? The plan has to include a comprehensive list of contacts from the Coast Guard and environmental agencies to local authorities and any relevant emergency response teams.
So a who's who of spill response.
Exactly. And it's not just a list of names and numbers. The plan needs to outline the exact procedures for contacting each entity, including primary and backup methods.
So if the phone lines are down, what if the internet is out?
You need to have a plan B, C, and maybe even D.
Makes sense. Communication breakdowns in an emergency situation can be disastrous.
Absolutely.
So once everyone's been notified, what happens next?
That's where spill mitigation comes in. This section outlines the immediate actions the facility will take to stop or slow the spill.
Like shutting down transfer operations, activating emergency valves, deploying containment booms. Anything they can do to minimize the spread of the spill.
Like applying a tourniquet to stop the bleeding.
Exactly. And the specific actions will depend on the facility's layout, the type of spill, and the equipment they have available.
It's a customized playbook for stopping the spill at its source.
But what about the cleanup itself? That's got to be a whole other level of complexity.
That's where the response activities section comes in. This is the game plan for containing and cleaning up the spill once those initial mitigation efforts are underway.
So deploying more booms, skimming oil off the water, using sorbents to absorb the spill. All those classic cleanup techniques we see in the news.
Exactly. But the plan goes beyond just listing the techniques. It has to outline specific strategies and tactics, taking into account the characteristics of the spill, weather conditions, and the resources available.
So it's not just a matter of throwing everything at the problem and hoping something sticks.
Not at all. It's about having a well-coordinated and strategic approach, maximizing the effectiveness of their response and minimizing the environmental impact.
And all of this takes a lot of manpower, right? How do they ensure everyone involved knows their role and who they report to?
The response plan has to include a clear chain of command, outlining roles and responsibilities for every member of the response team, from the on-scene commander to the cleanup crews. Everyone needs to know where they fit in the bigger picture.
It's like a military operation requiring coordination and discipline.
Exactly. And the plan also addresses logistics. Things like where to stage equipment and personnel, ensuring a steady supply of materials, and even outlining waste management procedures.
So they're not just cleaning up the spill, but managing the entire operation from start to finish.
Precisely. And they can't forget about the impact on the surrounding environment. The response plan needs to address the protection of fish wildlife and sensitive habitats.
So it's not just about containing the spill and cleaning up the mess. It's about minimizing the ecological damage as well.
Exactly.
What kind of measures do they take to protect those sensitive areas?
It can involve deploying protective booms to keep oil away from sensitive shorelines. Using specialized wildlife deterrents to keep animals away from contaminated areas. And even relocating animals if necessary.
It's a reminder that an oil spill isn't just a threat to human activities. It impacts the entire ecosystem.
Absolutely. And these response plans are designed to take a holistic approach to environmental protection, recognizing the interconnectedness of all living things.
So we've covered notification, mitigation response activities, and even protecting sensitive environments. What happens to all the oil, contaminated material that's been collected?
The disposal plan comes in. It might not be the most exciting part of the response, but it's crucial. The collected waste can't just be dumped back into the ocean or tossed in a landfill.
So where does it go?
The disposal plan outlines exactly how the collected waste will be handled, transported, and ultimately disposed of. It might involve transporting it to a licensed treatment facility, incinerating it under controlled conditions, or even using it as fuel in certain industrial processes, if that's permitted.
It's like a whole separate operation.
Yeah.
Managing the hazardous waste generated by the spill.
Exactly. And the plan needs to be specific.
Right.
Identifying the companies or facilities responsible for each step of the process.
Okay.
Ensuring everything is done safely and in compliance with all regulations.
So we've got the action plan covered.
Okay.
Who to call, how to contain the spill, how to clean it up, and how to dispose of the waste.
Right.
But all of that takes trained personnel, right?
Absolutely. That's where the training and exercises section of the response plan comes in.
Okay. So it's not enough to just have a plan on paper.
Right.
They have to make sure everyone knows how to execute it.
Exactly.
Yeah.
This section outlines the facility's training program.
Okay.
For anyone involved in spill response,
right,
they need to know their roles, the procedures, how to use the equipment.
Yeah.
It's all about ensuring everyone is ready to act quickly and effectively when a spill occurs.
What kind of training do they go through?
It's a comprehensive program that covers everything.
Okay.
From initial notification and spill assessment to containment, cleanup, and disposal.
Right.
They might even have specialized training for dealing with different types of oils or hazardous material.
So it's not just a one-time orientation video.
Right.
They're constantly learning and refining their skills.
Exactly. And to make sure everyone is truly prepared.
Okay.
The plan also has to outline the facility's exercise program.
Okay, so this is where they put their training to the test.
Yes.
Actually simulating spill scenarios and practicing their response.
Precisely. The plan describes the types of exercises,
how
often they're held, and what they hope to accomplish with each exercise.
They're like tabletop exercises.
Yeah.
Where they walk through the response plan step by step.
Right.
And full-scale drills with actual equipment and personnel.
Exactly. They might even stage surprise drills.
Wow.
To test their reaction time and ability to adapt to unexpected situations.
It's all about being ready for anything.
And I bet those exercises are valuable learning experiences.
Yeah.
Even if everything doesn't go perfectly according to plan.
Right.
The plan should include procedures for evaluating the effectiveness of each exercise.
Okay.
Identifying any weaknesses and making adjustments as needed.
Right.
It's a continuous improvement process, practicing, evaluating, and refining their response capabilities.
So the response plan itself is constantly evolving, just like the threats they're preparing for.
Exactly. And that brings us to the final section of the main body of the response plan.
Okay.
Plan review and update procedures.
So this is all about making sure the plan stays relevant and up to date.
Precisely.
Yeah.
The plan has to establish a schedule for regular reviews, ensuring it reflects any changes in regulations, best practices, or facility operations.
Right.
They also need to account for new technologies, equipment upgrades, or even changes in the types of oils or hazardous materials being handled.
So it's a living document constantly being revised and refined.
Exactly. And the plan should outline clear procedures for documenting those revisions.
Right.
And communicating any changes to the entire response team.
Makes sense. You don't want anyone working from an outdated playbook when a spill occurs.
Absolutely.
Okay, so we've covered the main sections of the response plan.
Yeah.
From initial notification to ongoing plan review.
Right.
But we can't forget about those intriguing appendices.
Ah, yes. The treasure trove of detailed information.
We mentioned these briefly before.
Yeah.
But I think they deserve a closer look.
Okay.
What kind of information is tucked away in those appendices?
The appendices provide a wealth of facility-specific details that are crucial for an effective response. It's where all those granular details come into play, giving the response teams a clear picture of what they're dealing with and how to handle it.
So let's dive into those appendices, starting with Appendix A.
Okay.
What mysteries lie within?
Appendix A is dedicated to facility-specific information.
Okay.
It's like the facility's fingerprint, outlining its unique characteristics and capabilities.
So it sets the stage for the rest of the plan.
Yes.
Providing context and background information.
Exactly. It includes a comprehensive physical description of the facility, covering everything from its location layout and surrounding environment to the types and capacities of its storage tanks, transfer systems, and any other relevant infrastructure.
So a snapshot of the facility's anatomy and how it operates.
Exactly. It's like a blueprint combined with a user manual.
Right.
They also have to include information on the specific oils and hazardous materials handled at the facility, including their properties, potential hazards, and any special handling precautions.
So the response team does exactly what they're up against.
Precisely. And to further contain potential spills, Appendix A identifies the very first valve that separates the transportation-related parts of the facility from any non-transportation areas.
So if a spill occurs during a transfer, they can isolate that section and prevent it from spreading to other parts of the facility.
Smart. It's all about minimizing the damage and focusing the response efforts where they're needed most.
Okay, Appendix A, the facility's fingerprint.
Yeah.
Checked off the list. What's up next?
Appendix B is all about communication.
Okay.
The list of contacts.
Right. We touched on this before.
Yes.
But clearly, communication is so important in a spill response.
Absolutely.
That it warrants its own appendix.
This isn't just a random phone book.
Right.
It includes contact information for every individual and organization that plays a role in the response.
Right.
From the qualified individual and their alternates.
Right.
To the Coast Guard.
Yeah.
Federal, state, and local agencies. And even contracted spill response organizations.
So it's a lifeline for connecting with the right people at the right time.
Exactly. And the plan has to outline procedures for keeping this contact information current.
Right.
Ensuring no one's trying to call an outdated number in the middle of an emergency.
Okay, communication covered.
Yeah.
What's next on our appendix adventure?
Appendix C is where we get into the nitty-gritty of equipment.
All right.
It houses the equipment list and records.
Ah, yes. Appendix C, our multipurpose tool.
Yeah.
We already know it plays a role in evaluating response resources and equipment effectiveness.
Right.
But within the context of the response plan, it's all about taking inventory.
Exactly. Think of it as a detailed shopping list for spill response.
Okay.
It lists every piece of equipment the facility has available, along with its location maintenance records and any relevant specifications.
So if they need a specific type of boom or a certain absorbent material, they know exactly what they have, where it is, and whether it's ready to go.
Precisely. And the level of detail is impressive.
Okay.
For oil recovery devices, they have to list the effective daily recovery rate. Which tells you how much oil it can collect per day.
So they can assess their overall cleanup capacity.
Exactly.
Based on the equipment they have.
For containment booms, they need to specify the boom height.
Okay.
Which tells you how deep it extends into the water.
Right.
And how much of a spill it can contain.
It's all about having the right tools for the job and knowing their capabilities.
And for communication equipment, Appendix C lists the types and quantities available.
Okay.
As well as the primary and secondary radio frequencies used.
Yeah.
It's about ensuring seamless communication, even in challenging environments.
Okay. Appendix C, the equipment inventory checked. What about Appendix D?
Appendix D takes us back to the realm of communication.
Okay.
But this time it's about the overall strategy.
Right.
Communications plan.
So this is where they outline how they'll manage the flow of information during a spill response.
Exactly. It details the primary and backup communication methods they'll use.
Okay.
Ensuring they can stay connected even if some systems fail.
Right.
They also need to address communication within the facility, at remote response locations, and even with external entities, like government agencies and the media.
So it's about coordinating communication across all levels.
Right.
From the on-scene responders to the public.
Exactly. And having a clear communication plan can prevent confusion delays and misinformation, which are all critical factors in an effective spill response.
Okay. So Appendix D is the communication playbook.
What about Appendix E?
Appendix E is all about safety.
Okay.
The site-specific safety and health plan.
So this is where they focus on protecting the responders themselves.
Yeah.
Recognizing that spill cleanup can be a hazardous job.
Absolutely. This plan outlines safety procedures and precautions for all response locations and activities.
Right.
Think personal protective equipment requirements, hazard communication protocol.
Decontamination procedures and emergency medical response plans.
So they're not just focused on cleaning up the oil, they're also taking care of the people doing the cleaning.
Exactly. And the specific measures will depend on the type of spill.
Okay.
The location and the tasks being performed.
Right.
Cleaning up a gasoline spill in a confined space will require very different safety procedures than cleaning up a crude oil spill on open water.
It's about adapting the safety plan to the specific risks involved.
Precisely. And this appendix might also address things like worker training, safety briefings, air quality monitoring, and even long-term health monitoring for anyone exposed to hazardous materials.
So they're thinking about both the immediate safety of the responders and their long-term health.
It's a comprehensive approach to safety, recognizing that spill response can have both short-term and long-term consequences.
Okay. Appendix E, the safety manual checked.
What about our final appendix?
Appendix F.
Appendix F is our glossary of terms.
Okay.
The list of acronyms and definitions.
Ah, yes. a crucial tool for deciphering the often complex language of spill response.
Exactly. Response plans are filled with technical terms, jargon, and abbreviations.
Right.
Appendix F ensures that everyone involved understands the terminology, preventing misunderstandings and misinterpretations that could jeopardize the entire operation.
Clear communication is paramount in an emergency situation.
Absolutely. So Appendix F acts as a translator, clarifying any unfamiliar terms and acronyms used throughout the plan.
Okay, so we've covered all the appendices.
Right.
The facility's fingerprint, the contact list, the equipment inventory, the communication plan, the safety manual, and even the glossary of terms. It seems like these response plans leave no stone unturned.
They're incredibly detailed, covering every aspect of spill response from the initial notification to the final disposal of waste.
Right.
And they require a significant investment of time, resources, and expertise to develop and maintain.
But when you consider the potential consequences of an oil spill, that investment seems more than worthwhile.
Absolutely. These response plans are a critical line of defense, helping facilities minimize the damage and protect both human health and the environment.
So we've explored the main sections of the response plan and delved into the depths of each appendix.
Right.
But we're not done yet.
Oh.
There are still some fascinating areas to explore. Like the specific requirements for different types of facilities and those intriguing vapor control systems.
Right. And we'll be diving into those specialized areas in the final part of our deep dive. Stay tuned.
I can't wait to uncover even more mysteries of these regulations. Welcome back to the deep dive. We've been knee-deep in the world of oil and hazardous material transfer regulations, exploring everything from spill containment to those incredibly detailed response plans.
And now we're going to zero in on a specific piece of the puzzle. Vapor control systems, or VCSs for short.
These systems are fascinating because they tackle a hazard most people don't even think about.
Right.
Invisible, potentially dangerous vapors.
You can't see them, but those vapors from things like gasoline or other volatile liquids can be just as hazardous as a liquid spill.
Wow.
Leading to fires, explosions, or even toxic exposure.
So it's like an invisible threat that requires specialized equipment and procedures to manage.
Exactly. And the regulations don't mess around when it comes to VCSs.
Right.
They lay out very specific requirements for their design, installation, and operation, ensuring they're robust and reliable enough to do their job.
Okay, I'm ready for a crash course in vapor control. Where do we even begin?
Let's imagine a typical VCS.
Right.
Like a ventilation system for your kitchen.
Okay.
But instead of sucking out cooking fumes, it's capturing and controlling hazardous vapors from things like loading and unloading operations.
Okay, I can picture that. So what are the main components of this specialized ventilation system?
Well, first you have the vapor collection system, which is essentially a network of pipes and fittings that gather the vapors from various points.
Right.
Think of it like the ductwork in your kitchen, but built to handle potentially flammable or corrosive substances.
So heavy-duty ductwork for heavy-duty vapors. What happens to the vapors once they're captured by this system?
That's where the vapor processing unit comes in.
Okay.
This is the heart of the VCS.
Right.
And it can take a few different forms, depending on what those vapors are and what the facility needs to do with them.
So different tools for different jobs.
Okay.
What are some of the options?
One option is a vapor recovery system, which is like a recycling center for vapors. It captures those vapors and either reuses them in the process or condenses them back into liquid form.
So not only are they preventing those vapors from escaping into the atmosphere, they're potentially reclaiming valuable materials in the process. That's pretty clever.
Yeah.
What other types of processing units are there?
If the vapors can't be reused, they have to be dealt with safely.
Right. That's where vapor destruction units come in. These units use methods like incineration or flaring to essentially break down the hazardous components of those vapors.
So if they can't be recycled, they're safely destroyed.
Exactly.
Yeah.
And the choice of which type of processing unit to use depends on several factors. Like how much vapor they're dealing with, what the vapor is made of, and the overall needs of the facility.
It sounds like a lot of careful planning and engineering goes into designing these VCSs.
It does. And the regulations don't just stop at the basic concept.
Okay.
They get into the nitty-gritty details outlining specific requirements for everything.
Yeah.
From the types of piping and valves used
Okay.
to the pressure relief systems and the instruments used to monitor and control the process.
So it's not just about having a VCS.
Right.
It's about having a VCS that's built and operated to incredibly specific standards.
Precisely. And the regulations also consider what might happen if something goes wrong within the VCS itself.
What if there's a sudden pressure surge?
Okay.
Or a valve malfunctions, or the processing unit has a hiccup?
Right.
The system needs to be able to handle those unexpected events without releasing vapors.
So it's like a safety system within a safety system.
Exactly. And those safeguards might include things like emergency shutoff valves,
All right.
pressure relief vents that can safely vent vapors if the pressure gets too high, or even automated systems that can quickly isolate parts of the VCS if a problem is detected.
Wow. Layers upon layers of protection.
Right.
It really highlights how seriously they take this vapor control issue.
They do. And it makes sense when you think about the potential consequences of a vapor release.
Yeah.
It's not just about preventing a bad smell.
Yeah.
It's about preventing a potential explosion or a toxic cloud.
Okay, so we've got a pretty good handle on how the VCS works at the facility level.
Okay.
But how does this all play out when a vessel comes in to load or unload?
Right.
Do they just hook up their systems and hope for the best?
Not at all. The regulations recognize that the interaction between the facility's VCS and the vessel's vapor control system is a critical point of vulnerability.
Yeah.
They have to work together seamlessly to prevent any releases.
So it's a coordinated dance.
Yes.
Between the shore-based system and the ship-based system.
Exactly.
Yeah.
And the regulations outline very specific procedures for how those two systems are connected.
Oh, yeah.
It usually involves specialized hoses or loading arms that are designed to handle both the liquid transfer and the vapor transfer simultaneously.
So it's like a two-way street.
Yes.
Liquid going in one direction, vapors going in the other?
Precisely. And the regulations even address the speed of the transfer, making sure the VCS can handle the volume of vapors being generated. Too much vapor, and the system could get overwhelmed.
So it's not just about making the connection. It's about managing the entire process safely and efficiently.
Exactly. And throughout the transfer, the VCS is constantly monitoring vapor concentrations and pressures.
Okay.
Like a watchdog looking for any signs of trouble.
So if something starts to go wrong,
yeah,
the system can sound the alarm and take corrective action?
Precisely. And that might involve automatically slowing down the transfer rate, activating emergency shutoff valves, or even alerting operators to intervene manually.
It's like having a built-in safety net for the entire operation.
And that level of automation is a key part of these regulations.
Yeah.
It's about minimizing the risk of human error.
Right.
And ensuring a rapid response to potential hazards even before they become major problems.
Okay, so we've gone deep on vapor control systems.
Right.
And I'm already impressed by the level of detail and planning that goes into just this one aspect of oil and hazardous material transfer.
It really highlights the complexity of this industry and the need for robust regulations to protect both people and the environment.
Absolutely. But before we wrap up this deep dive, I want to shift gears and talk about a specific type of facility that faces some unique challenges.
All right.
Tank barge cleaning facilities.
Oh, yes, the TBCS.
Exactly. And their job is inherently messy, right?
Yeah.
Cleaning out those massive tanks that have carried all sorts of substances has got to be tricky.
It is. And the regulations recognize that TBCFs need specialized equipment and procedures to handle the unique hazards they face.
Okay, so what sets them apart from other facilities we've discussed?
Well, first of all, they need a way to capture and control the vapors that are released during the cleaning process itself. Imagine opening up a tank that's held gasoline or some other volatile liquid.
Right.
Those vapors are going to come rushing out.
Not exactly something you want to breathe in.
Exactly. So TBCFs need equipment like vapor collection headers, which are like giant vacuum hoses that suck those vapors out of the tanks and send them to a processing unit, just like the ones we talked about earlier.
Okay, so that's the vapor control part.
Yeah.
What about the actual cleaning process?
Right.
How do they get all the residue and gunk out of those massive tanks?
They use a combination of high-pressure washing specialized cleaning solutions and sometimes even mechanical scraping or scrubbing.
Yeah.
It's a tough job.
Yeah.
And it generates a lot of waste.
So it's not just about cleaning the tanks. It's about managing all the waste that comes out of them.
Exactly. And that waste can contain all sorts of nasty stuff, depending on what was previously carried in the tanks.
So they can't just dump it down the drain.
Absolutely not. The regulations require TBCFs to have a comprehensive waste management plan.
Right.
That outlines exactly how that waste will be collected, treated, and disposed of safely and responsibly.
So it's like a whole separate industry within the tank barge cleaning industry.
It is.
Dealing with the hazardous waste.
And the regulations are just as strict for TBCFs as they are for any other facility handling oil and hazardous materials. They have to have those detailed operations manuals, response plans, trained personnel, the whole 9 yards.
It's a reminder that every step of this process, from transporting the materials to cleaning the tanks, requires careful planning, specialized equipment, and a commitment to safety and environmental protection.
Exactly. And that brings us to the end of our deep dive into this fascinating, complex, and often overlooked world of regulations.
It's been an incredible journey, and I think we've both learned a lot along the way.
I agree. And I hope our listeners have gained a newfound appreciation for the intricate web of rules and regulations that keep our waterways safe and our environment protected.
It's a reminder that while these regulations might seem invisible to most people, they play a vital role in preventing those catastrophic spills and environmental disasters that we often only hear about when it's too late.
Well said. And it's a testament to the hard work and dedication of countless individuals, engineers, scientists, regulators, and industry professionals who are working tirelessly behind the scenes to ensure these hazardous materials are handled responsibly.
So next time you see a tanker ship or a barge on the water, take a moment to appreciate the complex world of regulations. That keeps those operations running smoothly and safely.
And remember, knowledge is power.
Yes.
The more we understand about these regulations, the better equipped we are to advocate for responsible practices and to hold ourselves and others accountable for protecting our planet.
Thanks for joining us on this deep dive.
Of course.
Until next time, keep exploring, keep asking questions, and keep learning about the fascinating world around us.